Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized conversations. Today, we're talking about robots, specifically how to get robots to move with the kind of athletic grace we see in humans.
Right, we've all seen those incredible videos from places like Boston Dynamics with the Atlas robot doing parkour or Spot, the robot dog, dancing. It looks amazing, but what you don't see is the massive amount of engineering and hand-tuning that goes into teaching the robot every single one of those moves.
Exactly. It's a huge challenge, but what if there was a better way? What if you could just show a robot a video of a human doing something, and the robot could learn to do it too? That's the core idea behind a new paper called ZEST, Zero-Shot Embodied Skill Transfer for Athletic Robot Control.
That's a mouthful of a title, but it's packed with cool ideas. Let's break it down. ZEST stands for Zero-Shot Embodied Skill Transfer. Skill transfer is simple enough. You're transferring a skill, like a cartwheel, from a human to a robot.
Embodied just means the skill is physical. It's performed by a body, in this case, the robot's body. But the really important part is zero-shot.
This is the magic ingredient. Zero-shot means that after the robot learns the skill in a computer simulation, it can perform it correctly in the real world on its very first try. Zero practice shots in reality. It goes straight from the virtual training ground to the real world.
So how does it learn? Well, the ZEST framework is not very picky about its learning material. The researchers showed it can learn from all sorts of sources. It can use high-fidelity motion capture data, the kind they use to make CGI characters in movies.
But it can also learn from much noisier, less perfect data. They used regular videos shot on a phone, which they call ViCap for video captured motions. And even cooler, it can learn from keyframe animations, movements designed by an artist that might not even be physically possible for a human.
And all of this learning happens in a simulation. The robot essentially gets to practice the move millions of times in a safe, virtual world. The technique they use is called reinforcement learning.
Reinforcement learning, or RL, is a bit like training a pet. The system gives the robot a reward, a virtual pat on the head when it does something right, like moving its arm closer to the way it looks in the video. If it messes up, it gets no reward. Over millions of trials, the robot's policy, you can think of that as its brain, gets better and better at figuring out the sequence of actions that will get it the most rewards.
And what makes ZEST so special is that it streamlines this whole process. A lot of other methods require engineers to do very complex things, like manually telling the system every time the robot's knee or hand is supposed to touch the ground. ZEST skips all that. The robot figures out the contact points on its own.
It also uses a couple of really clever training tricks. The first is called adaptive sampling. The system is smart enough to recognize which parts of a move are the hardest for the robot. Maybe it's the moment a handstand transitions into a cartwheel. ZEST then makes the robot practice that specific tricky part more often, instead of just repeating the easy bits over and over.
The other trick is something they call an assistive wrench. This is my favorite part. For really dynamic moves like a backflip, the simulation acts like a virtual gymnastics coach. It gives the robot a tiny invisible push or pull to help it keep its balance and not fail right away.
Just like a coach spotting a gymnast, and as the robot gets better and more confident, that virtual assistance gradually fades to zero until the robot is doing the whole move by itself.
These tricks help the robot learn much more efficiently and tackle much harder skills. Which brings us to the results. What did they actually teach the robots to do?
The results are seriously impressive. They tested ZEST on 3 different robots. First, the big humanoid, Atlas. They taught it to do an army crawl, complex breakdancing moves, and a forward roll. These are skills that involve the robot's whole body touching the ground in complicated ways, which is notoriously hard to control.
Then they used a smaller humanoid robot, the Unitree G1. Using only video footage of a person, they taught the robot to do ballet, a soccer kick, and even to climb up and down a large wooden box. This shows it's not just about flashy acrobatics, but also about interacting with objects in the environment.
And finally, they used Spot, the 4-legged robot dog. Since Spot doesn't have a human-like body, they used animations to teach it skills, and they taught it some wild ones like a continuous backflip and a full barrel roll.
Wow. So it works on different body types, learning from different kinds of data to perform a huge range of athletic skills. It's truly a general approach, and the fact that this all transfers to the real world, zero shot, is a huge step forward.
So what's the big picture here? Why does this matter? Well, this isn't just about making robots that can do cool party tricks. It's about scalability. Our world, our homes, our cities, our workplaces is designed for the human body.
Humanoid robots that can move and interact with that world in a human-like way could be incredibly useful. Think about disaster response, where a robot might need to crawl, climb, and navigate complex debris, or in logistics, or even elder care.
But for that to be practical, we need to be able to teach them a vast library of physical skills easily. We can't have teams of PhDs spending a year just to teach a robot how to open a specific type of door. ZEST points to a future where teaching a robot a new skill could be as simple as showing it a video. It's a scalable way to build physical intelligence.
A fascinating paper and a glimpse into a very agile future for robotics. That's all the time we have for today.
Thanks for tuning in to Daily Papers.